Okay, uh, we're going to we're going to do a revision basically on chapter 4. Okay, as I've said, it is about. If we look at the first question there, it explain the term distribution factor and of an alternator. Beste, you don't know. It is that is question 4.1. Is the EMF, we say the X, sorry, let me just, we say it's a actual EMF obtained to the EMF that would be obtained what if the coils, oh sorry, yeah, when I'm going towards defining a pitch factor. It's the same statement for a pitch factor. We say the coils are what? Full pitched. But your own question take distribution factor. When we talk of a distribution factor, we don't talk about the coil. We talk about none if the conductors are concentrated in one slot. Okay, so you make the same statement without defining pitch factor. And you say actual EMF obtained to the EMF that would be obtained if, for a pitch factor we say if the coils were full pitched. For a distribution factor we say if the conductors were concentrated in one slot. Okay, so the first question is the banana. It's a calculation. Question 4.2. We first read the question, guys, before we answer. The question, an 850 kVA, 4550 Hertz, three-phase star connected alternator has a resistance of 0.4 ohms per phase. A certain field current produces a short circuit current of 175 amps and an open circuit terminal voltage of 1500 volts. One wants us to calculate the synchronous reactance. Both wants us to find the full load percentage voltage regulation at the power factor of 0.8. You must first understand, but okay, after this question, we can see that in theta alone, you have voltage what? Regulation. That topic here, voltage regulation. Yeah, alternators. So we highlight again when we write things that are important. So here we are given apparent power, ne? And I've said power many times that it's normally given power to find a current. Ne? So we're given apparent power which is 850 kVA. Ne? It's an apparent power, and you would expect that with generators, ne? Because power generators are rated in kVA, not in kilowatts. You'd see where motors will be given a watts instead of apparent power. Where alternator will be given a kVA. If you look at the nameplate generator, you'll never see generator per kilowatt. Okay? Then we are given a terminal voltage. But it's a line terminal voltage. 4,500 volts. I've said a given voltage is always the line voltage. We are given a frequency, it's 50 hertz. We are told that it is a three-phase. So we are dealing with a three-phase calculation here. You must know that three-phase. Then they say it's star connected, and they say it's an alternator. Okay, we know we are doing calculations for alternator. Then with the armature resistance, but has an armature resistance of 4 ohms per phase. Okay, given the resistance. Normally, guys, what did we say about a short circuit and the open circuit test? Is to find synchronous impedance yethu ingekho given. That is why the question will give you data about the short circuit and open circuit test. The data being that a certain field current produced ubani. So a certain field current gave us a short circuit current of 175 amps. Then an open circuit terminal voltage of what? So I give an open circuit terminal voltage, that is 1500 volts. So the mistake endiyenzayo ke ngoku apha is to say that open circuit voltage phase, na? It's supposed to be a what? A line, na? It's supposed to be a line. So I'm supposed to say EL naught. Okay? So the first thing you do, okay, the best thing to do is to deal with the voltages zakho, ne? First, ne? With phase value. Why are we taking our voltage to phase value? Is because this is a what? A star connection. Line voltage no phase voltage are not the same. And we test about in what? In phase values. So, siyibala njani synchronous impedance, guys? Xa sinikwe i-short circuit test no open circuit test, it's equals to, we're using Ohm's law. The open circuit what? Voltage over short circuit what? Current. Open circuit voltage over what? Short circuit current. So what is our open circuit voltage? We do have it, but we have it in a line. It's 1500. So let us take it to a phase voltage. What is the answer? Go. 866 0.25 there volts. Okay, current we don't have to convert, it's a star. Current yatini is the same throughout. Okay. Okay. Now we can calculate the synchronous impedance, which is going to be the open circuit voltage, which is 866, ne? Comma bani? 045. 025. Okay. Over what is the short circuit current? 175, ne? So impedance here too is going to be 4, 4,949 ohms. Okay, we are done with that one. Nah? The next question says, basibale ntoni? A percentage regulation at a power factor of 0.8 what? Lagging, ne? A percentage regulation kanene guys sibala njani? Okay. Voltage regulation, it's terminal voltage when full load is switched off minus the terminal voltage at full load, né? Over the terminal voltage at full load times bani. Yebo? Okay. The terminal voltage at full load is sinayo, ne? It is 4,000 bani 500, but ke kwintoni ekwiline must take it to a phase. But a synchronous reactance. Let me check. Oh, but a reactance. So I haven't completed that. What? Thank you, ne? So guys, I calculated the synchronous impedance. I haven't completed the entire question, sorry. Bafuna pana the synchronous what? Reactance, not impedance. Oh, yabo. But we are still in the right direction because xa sesibala ke ngoku sinentoni synchronous what? Because kunyanzelekile uyibale kuqala intoni synchronous impedance. Then uzothi ke ngoku i-synchronous what? Reactance the synchronous reactance is going to be the square root synchronous impedance, né? Squared minus the resistance squared, né? We use the formula for the Pythagoras theorem. So what is the impedance? 4,949 squared minus what is the resistance? We're given the resistance. It was 0,4. Four comma three. Okay. This is where the question ends. 4,391. Okay. Then we can go to this question bese kuyo ngoku ne. Bese i-voltage regulation sibala njani? Is the terminal voltage when full load is switched off minus the terminal voltage at full load over terminal voltage at full load times ubani 100 ne. Bese sinayo terminal voltage at full load ne kubani ku 4,500 is that given voltage. So kumele sise kuntoni kumele sise thina kwi-phase because yi-live. Xa siyisa kwi-phase izoba mbani 4,500 over what? Root 3. What are we getting? But 4, 5, eh? Oh, okay. 2, 5, 9, 8, 7, 0, 7, 6. Okay. Okay. We have intoni i-terminal voltage at full load. Into esingenayo ke ngoku yintoni? I-terminal voltage when full load is what? Switched off. Sibala njani yona? We look at our power factor. What does our power factor say? It says what? Lagging, eh? Our power factor is saying what? We say plus or minus lagging? Plus, yes. So we say it is the terminal voltage at full load. Then we put a positive what? Sorry. We put a positive angle since it is what? Lagging. Plus if volt drop due to the what? Resistance. Ne? Then yintoni lena sithetha ngayo guys? Sithetha nge-alternator. We're talking of the alternator. Ne? When we are talking of the alternator, we put bani under a volt drop due to the resistance, put 0. Ne? Then motor we put bani 90. Ne? Nekhumbula? Then volt drop due to the what? Reactance we put 90 degrees. Yo sorry. Motor we put bani pa 180. Motor we put 180. Motor up we put what? Negative 90. Sorry. So into engenayo phana yintoni? It's the current for me to be able to calculate voltage drops. I-current siyibala yintoni? Nge-power given. And the power given here is the apparent power. Can use this formula. Okay, we can say upper V line is equals to what? V phase. So we don't have to convert the current. We are using line values, ne? Xa sisebenzisa u-root bani? 3. Xa sisebenzisa u-root 3, sisebenzisa ntoni? I-line values. So I'm given apparent power ngu 850 times 10 to the power of 3 is equals to root 3. What is the line voltage? 4,500. Then we can get the current. What is the current? Kubani? Is equals to 109, comma 055 volts. Now we can calculate our, sorry? So why am I saying volts? The current, so I'm supposed to say amps. Thank you. Now we can calculate if voltage drops zethu, ne? We can calculate if voltage drops zethu. So if voltage drop due to the resistance is going to be current, which is 109,055 times what is the resistance? Resistance ibingu 0, bani 4. So bani volt drop due to intoni? Resistance. But 43, 6 622 volts, ne? And if volt drop due to the reactance, it's going to be 109,055 times what is the reactance? Sesayibala mani go 4,391. Dot 4,9 ayiyo le ngu-4, apha bekusuppose ubani ngu-4,933 kanje ohms. Okay, so it's 4,933. Bani answer? Ku 5 537, 968. So, ne? Okay, now that we got it, voltage drop, say 2, we can now substitute the formula to find the terminal voltage when full load is what? It's switched off. So terminal voltage when full load is switched off is going to be, what was the phase voltage kanena? 2598, 076. 2598, 598, 076, ne? Then we put banpa or 0, ne? Okay, I see that I'm going to have a limited space here. Let me remove that. So, plus, what is the volt drop due to the resistance? Go 4, 3, 622. 43, 622. We put an angle of Bani. Put an angle of 0. Why did I put 0 there when they put up? I'm not supposed to be putting what? Oh, 0, ne? I'm supposed to put the angle here, a power factor. In power factor, it was saying 0.8 what? Lagging, ne? So, the angle ka 0.8 was 0, sorry, with 36, ne? Is 36.8 what? So that is the angle I'm supposed to put there, ne? Unless we take unit power factor, benzofaka 0 pha, ne? Because angle ka unit power factor man was 0. So I'm going to put 36.87. Then I put L0 under one volt drop due to resistance. Then volt drop due to the reactance is going to be 537.968. 968. We put Banipa, we put 90 degrees. So you're going to add for me Pana, and then going to add in rectangular form, then you place the answer yakho in what? Polar form. Unike i-value esizoyifaka apha sikwazi ufumana ntoni? I-voltage what? Regulation.